topic called DenseNet. So DenseNet is one of the very familiar deep learning model, and it is for especially medical segmentation also. Here the DenseNet have lot of features. Let's discuss the basics of the DenseNet one by one and compare with the DenseNet also. Here there will be a challenging problem arises when you go for the deep CNN, that is called vanishing gradient. This vanishing gradient generally is solved with the help of this deep learning method called deep learning model, that is DenseNet, because it initially consists of a lot of layers is there, and here every layer connected to another layer continuously here, and it is helpful to once helpful to resolve the vanishing gradient problem, and also is follow the feed forward fashion also. The layers are connected, and here there will be a layers is there like a dense connectivity, and there will be a dense block and transition layer, and apart from we have one more term called here, that is growth rate here. Here first of all dense connectivity, because here each layer always connect to all the previous layer through concatenation compared to the addition, because the addition supported by RESTnet, but here concatenation is supported here, and it supports the maximum future use also, because always the density ensure every layer has access to all the previous features, and strengthening the gradient propagation, and helpful to achieve the efficient learning also. And exponential connection there, this have the some formula like let's consider that there will be a L layers. If a L layers, the density can create L of L plus 2 by 2 direct connection here, and visualizing the or see the architecture of density architecture. Generally the architecture concept of input layer followed by dense block, where concept of multiple blocks like not only multiple blocks, it concept a convolution, multiple convolution also, and end with the translate and the concept of transition layer also. Here the input flow is that here every layer always receive a concatenated feature map from all the previous layer only. Then dense blocks there, these are the groups of connected layers were helpful to process the information. And next important is transition layer. These are connected between the dense blocks, and moreover it will try to compress the points, that also help to reduce feature map dimensions between the blocks here. And very important term, parameter called very important term called growth rate, that is represented by always k, because this helpful to control the number of new feature maps added by the each layer here. If you take anything, you can consider input image size, then we can calculate the growth rate also. Then key components. So we know already about dense block, because these are layers within the block connected, where receiving input from all the previous only. Transfer layers are these always helpful to employ one by one convolution, where combined with average filling to compress the feature maps, and reduce the spatial dimensions between dense blocks, that is downsampling. And bottleneck is there, because generally it follow one by one convolution before the 3 by 3 convolution, and also helpful to reduce the input dimensions. And growth rate, the hyperparameter very important, it also helpful to find or determine how many feature maps each layer contributes, and also balance helpful to balance the model expressiveness with computation efficiency. So the hyperparameter k is very important when it comes to the concept DenseNet. Apart from this, there will be a lot of models at DenseNet 1 to 1, 201 and 264 and so. In the 2 for example, if you consider DenseNet 201, the 201 says about the layers here, number of layers. And the major advantage of this one is here, instead of DenseNet having a connection, but here DenseNet have the concatenation function here. Concatenation, because it helpful to know about the future information, and moreover it consists of many points advantages like information preservation, then parameter efficiency and gradient flow. And here the information preservation by we know, here the layers are connected continuously, and combinations are more here. And parameter efficiency, once compared to RESTnet, you have very less parameter, and helpful to achieve the better accuracy also, and so on. Then gradient flow is there. These are the strongest propagation through direct connections here. And then performance. So generally the DenseNet have variety of models like DenseNet 201, like that, and have the 20 million parameters here. And 4 benchmarks is there. We can work with it will show the good performance with the data set called CIFAR 10, CIFAR 100, and SVHN also, and efficient gain. So there will be a 50% efficient gain possibilities there. And here DenseNet 1 to 1 and 2 1 are always helpful to achieve the top tier accuracy and increase the computational efficiency also. And then where we can use the DenseNet, we can use the DenseNet for medical image excellence, computation tasks, as well as the mobile embedded AI also. And limitations the memory usage, feature map growth, and training complexity. So I hope that today you know the basics of DenseNet, what is DenseNet and why we need DenseNet, and what is the use of this hyperparameter K, and how we can visualize the, or else what is the architecture of the basic architecture of DenseNet, and where you can use the DenseNet. Thank you for watching the video. If you like the video, please subscribe, share with your friends. Thank you.